So we're here with Bernard, and so you get this prize today.
Yeah, that's the result of the video you took last year, so thank you for that.
Really?
Yeah.
No, I mean, seriously, why did they give you this?
Yeah, because the video we took last year had so many hits on YouTube that it's pretty much the top search result when you search for Linaro.
Oh yeah, it says online superstar actually.
Yeah.
But I mean, they could give you this prize for lots of other things, no?
Well, all the people at Linaro do great things, so pretty much everyone should be getting those prizes.
Yeah, everybody does as much as you do, or what?
That's what Linaro is all about. If you don't work like at least 80 hours a week, the chances are you're not a Linaro person.
That's cool. So let's see what's going on your screen there. Just tonight. What are you doing? You connected this to the wall right here while you were in a session, or?
Yeah, actually after getting out of a session because I was running out of batteries. So right now what we're seeing is a build failure.
Can you close the screen a little bit like this? The build failure.
Yeah. I'm trying to get Android to build with Clang, which is the compiler from LLVM. We're not trying to replace GCC, but we're trying to see whether or not Clang is a valuable alternative, and also trying to help fix bugs in all the projects. Using different compilers, we'll usually find a different set of possible bugs with compiler warnings and stuff. So even if we never decide to release a build that's actually based on this, it's probably going to be helpful.
Can you describe more what it is? What is that?
Yes, so pretty much everyone will have heard of GCC these days. That's pretty much the compiler that's being used for everything. And lately, the LLVM project has come out with a different compiler called Clang that also generates pretty good code that can also target the ARM architecture. So it's definitely not something we should be ignoring. So while it is, in effect, duplicating the GCC effort, it can't hurt to have some competition there. And obviously, different compilers will find different potential bugs, and all of those should be fixed.
So what is it to put GCC and Clang and stuff into Android? Is that what you're doing? What is it?
No, that's actually another project that I've worked on that you will probably see more of in the afternoon because that's part of our demo session. Here we have a nice Android phone that's running GCC. Let's see what version exactly.
So can you describe what GCC does on Android?
Yeah, GCC is a compiler, so you can use it to generate code. Usually the way you develop something for Android is developing it on your normal computer, using a cross compiler and then pushing it over, seeing if it works. And with those Android devices getting more and more powerful, it suddenly starts making sense to run the compiler just straight there, not need a computer in between. So obviously this box is not really fast enough to build the entire Android project without falling asleep or whatever, but this can be really useful to test small pieces of code.
So,
and to make it easier to write that, we also put VI on. So anyone who is used to working in a normal Linux command line environment will just find his way around here.
So is this the Linaro image?
Yes. This is actually a special version of it that is also available on androidbuild.linaro.org. It's called Developer Galaxy Nexus. This is the regular Linaro Android image with the GCC and G++ and everything built in.
Since when? And since when are you doing this? Is it an experiment?
It's an experiment, but one that has been going on for quite a while. We've actually shown this in the Copenhagen Connect for the first time, but it didn't get a lot of attention because it was just done almost at the end of the conference.
You actually did it during the conference.
Yes.
So that was like the project during the hacking sessions over there?
Yes.
And since then, what have you maybe changed or improved or?
Since then, a lot of improvements have gone in. Like it's using a newer version of the linear toolchain, and also G++ is there and will actually link to STL port instead of the normal GNU STL. STL port and the GNU STL are a library that exports the same interface, the standard template library of C++. Android uses STL port by default because it's under a license that is more compatible with the rest of Android. And so it made sense to just hack G++ into using STL port instead of the regular GNU STL.
So is this basically running like an app, or?
Yes, it's running inside a terminal emulator, and that terminal emulator is an app. And it's all linked against the regular Android libraries like Bionic, so there's not, in fact, any other operating system stack running on it or the likes of that.
So it's just an app, and then you can start developing, building, and all that in Android. You don't need a laptop anymore, in theory.
Yes, right. There's also stuff like Make and other tools you will need to build code. So if you have a fast enough Android box, that can pretty much replace your desktop.
How soon? Is it fast enough?
There's actually some devices out there already that are almost there, like the Cortex A15.
Nexus 10?
Nexus 10 has an A15, so I actually haven't used the Nexus 10 yet. I don't know really how fast it is, but the specs look good, and a development board, the Arndale board, that pretty much is based on the same CPU, is pretty good. It's not as fast as a high-end machine, obviously, but good enough if you're not compiling giant code.
So you have this laptop right here. It's an HP, right?
Yes.
And this is Intel.
Yes.
So how soon do you think everybody here at Linaro Connect is just going to work around with ARM-powered device to do all their development and everything?
That's a good question. It might happen as early as next year because the ARM 64-bit architecture is coming out. And if that goes well, chances are it will just catch up with the Intel CPUs.
So, should we walk a little bit?
Yeah, we can.
So do you have some crazy ideas for the future?
Obviously, but they're probably not ideas I'll get to work on in a reasonable time frame, but maybe someone else will beat me to it.
So can you
For example, on the regular Linux desktop world, we have Wine for running Windows applications when we need to. And in a similar way, it would be interesting to have an iOS emulator running on Android. And a lot of the stack that would be needed for that is already there. There's the GNU Step project, which provides the Next Step API, which is what iOS is based on. And if you just adapt that to provide some of the iOS-specific functions, and then add a dynamic linker that reads the Mac-O format and converts it to ELF, pretty much like Wine has the PE loader, you could probably run some of those applications.
So are you saying, if I understand correctly, are you saying it's possible that maybe soon, if somebody does the project, someone needs, you don't have time, right? Are you too busy? But if somebody does this project, you are thinking that it might be possible to run iOS apps on Android?
Definitely. Probably not all apps are going to run. Wine doesn't run all Windows applications either, and those projects would be pretty similar in scope and also in the technologies used.
But how big, how much change do you need to do to Android to support iOS apps?
No change whatsoever. Basically, you'd use the GNU Step libraries and a custom application that parses the Mac-O code and turns it into normal code that can be read on the Android system, and that would run whatever iOS application you throw at it. I have some ideas on how to do this, so if someone is actually interested in starting that project, feel free to email me. I'll give you any tips, but I probably won't have a lot of time to actually contribute to it.
Can you describe a little bit more what some of the ideas?
Well, a lot of the code is already out in the open. There's GNU Step for the basic APIs. OpenGL is pretty much a common graphics layer that is used in both Android and iOS, so that's already quite compatible. Parts of the dynamic linker that can read the Mac OS stuff are open source, so you can just use that to parse whatever is in the binary format, get the ARM code that you want to run out of there, and just run it on top of Android.
So for some really talented programmers, how much time would it take? How much effort do you think this is?
Well, it would probably take a while. Like, Wine has been going on for 15 years or so and still isn't completely finished. But also it's a moving target. There's new iOS versions coming out all the time. They always add new APIs. So it's a project that would probably run for quite a while. But chances are the first applications could be running within a month or so, especially if you start with carefully crafted applications that only use a subset of commands that's already known to work.
Nice. And there's a way to get access to all these apps, or are they only secretly on the secret Apple server somewhere? How can people get...
Yeah, that's pretty much the problem. There's probably no way to get the application files out of the secret Apple server. But obviously, some of the application developers would be interested in having the applications running on Android, and so chances are the developers directly might be interested in sharing their applications with the rest of the world.
What should happen, and might have already happened at Apple, is that some of the Apple engineers would actually port iOS over to Android and then add an Apple store on Android.
That would be an interesting idea, but I don't see it happening.
That's just political, I guess.
Yes. I mean, it's always hard to replace a big piece of code you've written with some other code that someone else has written. That's just... people tend to get attached to their code.
And how about some other software on Android? Are you thinking about some... do you have some other crazy ideas about that?
Yeah, obviously, if the Windows mobile platform were to gain some traction, you could just use Wine to run applications written for that, which I know some people are actually working on. I've seen the Wine with an Android front-end presented at FOSDEM, so this might actually get started.
So basically, Microsoft probably should also get involved and support Android and put all their apps on Android. Is that what you're saying?
It's what I'm saying, but in the same context as they should put Office on Linux, and they should have done that 20 years ago.
And open-sourced Windows.
Obviously. Or just given the source code for that to the Wine project for better interoperability. But that's just not very likely to happen.
How about running regular Linux applications on Android? What needs to be done for that to happen?
That's actually another really interesting idea. One I've actually been working on. You've seen GCC running on my Galaxy Nexus. For command line applications, that's actually pretty easy to do these days. But what needs to be done is find some way to get the graphical applications to run. There's some rather incompatible stacks involved there. Android uses Surface Flinger to drive the display, while regular Linux uses an X server. This gap can be bridged. There is already an open source project that provides an X server on Android. What's still needed is basically compiling the applications that would use the X server directly on Android, and that includes some of the libraries like libx11. Those rely on some libc functions like system5 shm that is not currently implemented in Android. There's some ways around that, like you could put glibc on top of Android, or you could just rip the system5 shm functions out of glibc, put them into a separate library. And then the X server that's currently available for Android is missing some of the extensions that are used by Qt and GTK, and therefore pretty much all regular Linux applications, such as xrender and xresize and rotate. So those would still need to be implemented. But other than that, I think that's a strong possibility. And given for most interesting applications the source is available, it could be done in a much smoother way than relying on binary emulation like for the other two projects I was talking about.
So how do you do it more smoothly than emulation?
Well, you have the source, so you can just run the binaries, not the binaries, but you can just compile the source with the toolchain that is targeting Android directly and just generate a native Android application out of the same source code. It's just a matter of having the right libraries there, and that's, for the most part, blocked on the graphics stack a little. But it's not a gap that cannot be bridged.
So you're an Android guy, right?
That's actually a good question. I'm both a Linux guy and an Android guy. At Linaro, I'm on the Android team, working mostly on toolchain integration, but also porting to new devices. But outside of that, I'm with the Open Mandriva Foundation to work on desktop Linux. And so I'm pretty much on both sides of that.
But what we've been talking about now is iOS, Windows, Linux apps, all running on Android. Would an Android, let's say in a year from now, if somebody has worked on it, would it be slower than current Android? Would it be more bulky, would it be bloatware to support all these different languages?
No, because that's just different apps that you would install when you need them. They wouldn't be running when you're just sticking to regular Android applications. There might be some compatibility libraries, like, for example, a glibc-based stack to get System 5 shared memory that you would put on the phone, and that would effectively eat up some of the disk space, but wouldn't waste memory or anything.
So you could have a super smooth, super fast Android system a year from now with support from all kinds of new other languages. And it wouldn't be slower, it would just be faster actually. Android 6, Android 5,
yeah,
5.
I think that would be possible if enough people were to work on that.
But why isn't there enough people? If there isn't.
Those are crazy big projects. Probably people who could do it just have too many other things on their hands. And other people just wouldn't know how to get started, but obviously we are there to help out.
So you've got lots of things on your hands, right?
Yes. For example, I already mentioned I'm working on the Android toolchains. So there's a lot of work coming up getting Android to build with GCC 4.8, and lots of work coming up getting Android to build with Clang. Then comparing the output, seeing where one compiler does significantly better than the other, making sure that some feature that one compiler is using that makes it really a lot more efficient gets merged into the other compiler. So that kind of work takes up 80 hours per week? Yes,
minimum.
And more.
And more? In Switzerland?
Yeah. Obviously there's also weeks when you do a little less, but then there's other weeks when you do a little more.
And do you work on holidays too? Like here?
Yes. I can actually take a holiday, but I'll always at least check my mail or see what's going on, fix a broken build.
Maybe last minute you decide if you go or not.
Yeah, actually, it depends on when I'm going alone. Obviously, it's a last minute thing. I live in the Swiss mountains, so it's really easy for me to just take a tent and go out for a day or two. But if I intend to go with someone else, obviously it requires some planning on their side, because not everyone is as flexible as Linaro in terms of when you have to be in an office or anything.
So what do you think about Linaro?
I really like it.
Why? What's cool about it?
Oh, everything. There's so many people here who really understand what they're doing, who really care about what they're doing. It's really interesting projects that you work on. You can work from home all the time, except during those events, of course, which is really nice, especially if, like me, you have a dog and want to spend time with him.
So today there's a demo.
Yes.
So are you showing any faster Jelly Bean this time or something like that?
Not this time. We did that last year, and obviously we still have builds that are faster than AOSP. and we are still working on optimizing it. But we cannot show the same thing all the time. It would just be boring to do another demo of the same demo running on Linaro Android and running on regular Android, with the outcome that the Android one is just faster.
So, but is the Linaro Android faster than Google Android?
In many things, yes. Mostly because of the toolchain and also because of some optimizations we made in Bionic, which is the C library. There we replaced some of the string handling functions with specific routines written in ARM assembly that are targeting the Cortex A9 CPU directly. That just makes some of the most commonly used functions faster.
So 10 months ago when we did the video, it was 4.0.4. So lots of views on the video. Did Google use, how much of the Linaro code did Google use in Jelly Bean and in the latest Jelly Bean?
We have submitted a lot of changes upstream, but a lot of that is still stuck in the review process, which is related to how they work. They always make a release and then fork it into an internal tree, work on that, while the rest of the world is pretty much working off the release tree or of a Git master tree that is more or less close to the latest release tree and not that close to the internal tree they are working on. And when you submit a patch that doesn't apply to the internal tree anymore, usually you won't get a lot of their attention to review it and to integrate it into the upstream. So the best way to work there is to wait for the next release when actually the open source project is pretty much in sync with the internal tree, and then submit it again after making sure that it works in that tree. And then it will apply in the internal tree, and they're much more likely to actually take a look at it and merge it if it's good.
But but do you know if they've used some already in Jelly Bean?
Yeah, some of the code actually got in. One of the Bionic optimizations got in. I'm not completely sure which one it was. And some of the changes needed to make it compile with GCC 4.7 got in. Probably some of the changes needed to compile it with 4.8 will also get in pretty soon.
And they might include even more in the Android 5.0 maybe.
Yeah, of course.
But nobody knows.
Of course, there's always some work going on. We're always trying to get our patches upstream. Sometimes it's just not possible because of the difference between the trees. Sometimes they'll say that this conflicts with some other change they've already made, and sometimes the change they've made is actually better than the one we've made. So
at which point is it made better what they do? For what, for example?
Well, obviously, if you put two people on the same task, then the task is optimizing something. Sometimes person one will have a better idea on how to do it. Sometimes person two will have a better idea on how to do it. And sometimes a chip manufacturer comes in and drops a piece of code that optimizes it to work better with their chips. I think Qualcomm has been submitting some code to make memcopy faster. That's actually about the same performance as with the version we have.
Would you like to see Android 5.0, Android 6.0, where Google changes their process, where they become more open in what they're doing? That'd be cool?
Yes, that would be really great. It would make it so much easier for the rest of the world to contribute, and also to just see what they're planning to do and maybe prepare some applications that make use of the new features. But it's something that probably will not happen because of all the NDAs that are involved in device creation. We just need a more open world, but realistically that's probably not going to happen too soon.
So it's, what's it called, politics again?
Yeah.
But it could happen.
Obviously.
Because Android is so popular, maybe they don't need to hide from Apple and Microsoft what they're doing anymore.
Yeah, obviously. At some point it might happen, that would be great. Another thing that might happen would be that some other project decides to fork the Android project and work completely in the open. Well, that would be a nice project to work on, but obviously there's some drawbacks to that, like it would be hard to sync up with the next Android version.
All right. So, cool. So thanks a lot for the latest here at the Linaro Connect. So what is this stuff here?
This is the version of the Android NDK that we are going to release soon. It's pretty much identical to the regular NDK that you get from the Android website, except we've added 2 new toolchains to it. One is our regular Android GCC 4.7 based toolchain, the one that has been shown last year to run circles around AOSP builds. And the other is a new project that actually adds Clang, which is LLVM's compiler. So we just make 2 new compilers available. GCC is generally the one you want to use, and Clang is there so you can start experimenting because we expect it to be interesting in the future.
NDK?
Yeah, NDK is a native development kit. So this is all about running C++ code on Android.
So you modified it?
Yes.
And you modified it to add LLVM?
Yes, we are adding LLVM and, of course, the regular Linaro GCC 4.7, which is just a regular GCC built with a lot of Linaro patches to optimize it on ARM.
What is LLVM?
LLVM is a library, basically. It stands for Low-Level Virtual Machine, and that library generates machine code from bytecode. And on top of LLVM, there's Clang, which is basically a C++ compiler that generates bytecode that LLVM then can process into machine code.
So the other guy said that you did something just this week to make it work? What did you do?
Right. So actually before this week we had no plans to do this, and then in one of the morning sessions someone mentioned that we are going to provide LLVM builds from now on, that we have people working on it, and then we thought it might be an interesting project for this week to get Android to build with it. So we got started working on it. We didn't fully get through. We actually have a build that compiles, but then we flashed it to a device and it would just reboot instantly. We didn't have the time to debug this week, so we ended up producing a 50% build that has some of the lower layers like Bionic built with GCC, and some of the libraries at a slightly higher level, and also the kernel built with Clang.
So how much work is that? Just during those 5 days, how much work is it?
No, it was quite a bit of work because some code requires fix-ups, and there's also still some bugs in Clang that need workarounds or fixes. So overall, I'd say we spent around 30 hours this week to get this going.
Cool. And there were bugs? There were times it didn't work?
Yes. There's lots of times where it just failed to compile.
How do you find out how to fix it?
Well, obviously, when you have a failure at compile time, that's easy. You can just look at the code, see what the compiler is complaining about, and then determine whether the code is actually okay. If it's not okay, you fix the code. If it is actually okay, you either fix the compiler or you make some modification to the code that basically doesn't make any change, but that still makes the compiler accept it by working around the compiler bug.
And what are you trying to do here?
Yeah. So this is probably the most interesting part of what we're showing here. This is all running on a Galaxy Nexus. So the big screen is just showing what's running on the Galaxy Nexus. It's not a regular computer or anything. So we put a regular development environment on top of Android. That's a bit complicated to type upside down. We have VI complete with syntax highlighting. This is a piece of pretty bad C++ code that is totally unnecessary, but I wrote it that way to show that we can actually handle templates, that this is not just some minimal version of the compiler. Then we compile stuff. Let's turn all optimizations on. So no complaints from the compiler, so let's run it.
Your problem is that
and it does what we'd expect it to do. There's also some other tools that developers will want to work with, like make. We don't have a make file in here, so I'll just make it output the version information.
Taking all that stuff out of it.
Well, it works on Android does. When you start up the make.
So you see it's a regular make. And then another interesting part is object dump, which many people will be familiar with. It basically displays information about a binary. And in the case of C++, it shows a modification we made to the compiler. Let me just find it.
I don't know when my Arndale is going to show up, but eventually I want to run a typical.
So don't worry if you don't understand any of this. Most people don't, and it's not necessary to understand. But the interesting pieces are here.
We do it in a manual process.
This is pretty much equivalent to the output you'd see if LDD was there. This shows what libraries are being used. And you will see libstlport.so instead of libstdc++.so.6, which shows that we have patched GCC to do things the Android way, to use the version of the STL that comes with Android instead of the regular STL that comes with GCC.
Right.
So this is just, is it more than just an app? What is it? It's inside the whole Android firmware, or what do you call it, distribution.
Basically, it's just an app that allows you to write other apps, and that will, in the future, even allow you to compile the entire Android system and just reboot into the new one you've built.
Reboot into the new one you built?
Yeah.
How much you need for that to work?
Not that much, because all the basic components are there. You have seen GCC, you have seen G++, you have seen Make. But the Android build process uses a couple more tools, like it uses some XML processors, it uses a Java compiler, obviously. Those still need to be ported, but it shouldn't actually be that much work.
And you say it's just an app, but it doesn't work on other Android. It has to be the narrow Android built for that, right?
No, not necessarily. The way we've gone about this is we have just made it a part of the operating system. So when you download an OS image that has it integrated from android-build.linaro.org, you just get an image that contains the entire Android OS, including GCC and G++ and Make and VI and all the other goodies. But in theory, you can just extract them and put them onto a regular Android device. There's nothing that needs to be done for the system.
You can put it on the Google Marketplace, the Google Play Store.
There's a couple of reasons why that doesn't work right now. For example, we need write access to /system at the moment to install it. But we can work around that. There's a couple of ways. We can just generate an installation environment that puts it somewhere in /data/local. And we will probably end up doing that. But it's not something that has a big priority right now, so this could take some more time.
And this is useful because eventually people with just a little Android device can start developing. Is that what it means?
Yes, of course. And also it's useful. Well, for example, tomorrow I'm going to be on a plane for 13 hours and I don't have a laptop battery that can last that long. I don't have the money to go business class and just have a plug there. But a phone can easily last 13 hours, so time to do fun stuff even on that long flight.
How many things can you actually program with this system? How many things can you actually develop using this system? I mean,
anything.
The limits in speed
Well, obviously this is not as fast as a regular computer at the moment. So if you want to compile some large project like a Linux kernel or whatever, you have to be prepared to wait for a while until it finishes. But if you bring a bit of time to wait for it, or if you just type make and then switch to some game or whatever while it's running, you can basically just compile whatever you want. There's a little limit on what libraries you can use, but you can fix that by just compiling whatever library you want to use.
Nice. And how about stuff like Eclipse or whatever?
Like what?
Eclipse. What is that?
Oh,
That's
yeah.
different, right?
So that is basically an editor with some functionality that makes it easier to develop apps. We are not currently planning to port that because Eclipse is rather huge and can take down even a much stronger system. But in theory, there's no reason why people couldn't port it. There's a couple of things that make it a little more complicated because it's a graphical application and there are some incompatibilities between the regular Linux graphics stack and the Android graphics stack. So basically we'd also have to put on X11 server. But in theory it's possible, and probably at some point someone will make it happen because Android devices just keep getting stronger and stronger. And once they are comparable to a regular notebook or so, there's absolutely no reason why you shouldn't be doing development right there.
So by next Linaro Connect in a few months, in theory, developers could be doing the development on the Android stuff.
Yes, you see, to some extent it's already possible. We've just run an application we built here.
All these guys are going to be using it.
Yeah, obviously. It depends on what they want to do, and to some extent it depends on how many contributors we get to port interesting new stuff that can be used along with it, like new libraries. But in theory, there's nothing that prevents this from happening.
Explain what it is we're seeing here.
Okay, that's Werner's project, which is we're compiling Android with LLVM. Did you get all the text? Yep. So this is some benchmarks. That's the half LLVM one, and that is the stock Android compiled with GCC. And so we got the kernel compiled with Clang.
Yeah, the kernel and libpng and libjpeg and parts of Dalvik.
Parts of Dalvik. And then a bootstrap with the rest we compiled with GCC, and then we bootstrap and we did some benchmarks, and the numbers are very close to each other. Not sure you can see them, but yeah.
So what does it mean technically, all this stuff?
Well, it means that first it means the LLVM compiled, and it can run the code in Android. And it also means that it doesn't impact performance, or the performance is virtually identical. So we can, the project can continue and trying to compile the whole Android stack with LLVM, and then we can compare like benchmarks and stuff to see how good it is. But the biggest thing we gain here is not performance. It's compiling the same code with two different compilers. So then you get two different errors, you get two different diagnoses, and you tend to stick to the standard. Because if you all is compiled with just one compiler, you end up being lazy and accepting everything that just one of the compilers accept. But that's not the standard anymore. So if you have different compilers, it doesn't matter if it's LLVM or some other compiler. It gives you, a reason to fix the code rather than leave it broken.
So you were saying here you'd compiled only parts of the full Android with LLVM.
Yep.
I suppose that's because the other parts didn't quite work right. Is that right?
Yeah. So the other parts didn't work right because we found problems in the code that were some build errors, or the code itself was too complex for us to fix in a few days, or because LLVM was getting things wrong. So some examples were like code generation, that the thing that you wrote the patch for, plus so symbols, linkage types. It's kind of a black art that GCC does in one way, so you can do in different ways, and LLVM is doing slightly different, and they don't cross compile with each other, because that's the other thing, we're not using pure LLVM. we have to use Binotius, which is the back bus or the assembler and the linker and the tools they use to finally put all the things together. So it's not 100% LLVM, and that's it.
So how would you comment this work? How would you describe or how would you can you add some comments?
Well, I think it's great that someone is looking at compiling Android with an alternative compiler to GCC. As Renato was explaining earlier, building with multiple tool chains is a great way of finding minor errors in your code where you're inadvertently relying on unspecified behaviors in the compiler, where the one you've chosen might be working by accident. Using another tool chain lets you expose these things and fix them sooner.
So what do you think about what Bernard is able to do, what he does, what he did this week? He did something? What do you think?
Well, I gather this was a rather large undertaking to actually compile the Dalvik virtual machine and multiple libraries using LLVM as opposed to GCC.
Especially when the build system is 100% focused on the GCC tools and then tool chain.
Indeed, yeah. I see you wrote a wrapper script to actually make Clang look more like GCC.
Yeah.
Now, what was the most common error you ran into?
It was the linker errors, the linkage type errors. That's so it's static symbols or inline symbols. They get weak or weak ref, and they sometimes you get on the same file you get undefined symbol and duplicated symbol.
Okay.
Because of the linker was getting it wrong, so he was putting the wrong symbols in the object and then putting the duplicating the symbols in the final archive or the binary. So we got very odd errors.